Continuing with our dive into data analysis and problem solving, this week we're going to be looking at probabilities. I know when I took the SAT in high school, I really struggled with these probability questions. But looking back and studying it again, I realized that once you get the basic concepts of probability, conditional probability, and interpreting data tables, then these questions are really nothing to be afraid of. So today we're going to go over those concepts so you avoid the same mistakes that I made when I took the test. So to start, what is probability? Probability describes the likelihood of an event to occur. An event is something like flipping heads or choosing a green candy from a bag of colored candies. So that's the meaning, the interpretation, and how do we actually calculate probability? So the formula is the number of outcomes in our event divided by the number of total possible outcomes. Now we would often see this written as number of desired outcomes divided by the number of total possible outcomes. There are essentially two ways we're asked to use probabilities on the SAT. The first is taking data and calculating probabilities, and the second is the opposite of that. Given probabilities, predict data. So the first of those two is the more common, so we're going to start with an example of that right now. A survey asks Brown University students in the first week of school how they would describe their personal style, choosing from hipster, preppy, punk, or other. The results are then sorted by class year and reported in the table below. Based on the table, what is the probability of a random student from Brown identifying as hipster? So before we can start answering this question, we need to understand what we're looking at in this table. So this is what we call a two-way table, which is just a table that holds two variables of information. So though unlabeled, one is personal style and the other is class year, as we see there. The numbers seen in the table correspond to the number of data points corresponding to both the row and column of that number. For example, if we look to first year and hipster, we see that that says there are 55 students who are first year and hipster. Now we also have these totals at the bottom and the right. This tells us, for example, that there are a total of 350 hipsters and a total of 204 seniors if we just look at those numbers in the table. Okay, we know what we're looking at. Now, how do we use this information to find the probability that a random student is hipster? Let's plug into our probability formula. So we're looking for the desired outcomes, which in this case are the hipsters. So we look to our table, we find that there are 350 hipsters in total, and then the total outcomes are all surveyed students. We look to our total column, add those numbers together, and find that there are 772 students in total. We substitute into our equation, and then there we find, after evaluating, that the probability we were looking for is 0.45, also written as 45%. So this means that if we choose a student at random, there's a 45% chance that they would identify as hipster. What we just did was use data to find probabilities. What we need to do now is use probabilities to predict data. So here we see the same setup that we had before, but a different question. When we get a problem like this, we first need to find the probability associated, in this case, with a student being preppy. Once we find the probability, then we can predict the data. So let's first find the probability. Like before, we can substitute into our probability formula, as we see here. So our desired outcomes now are the number of preppy students, which is 212. Total outcomes from before, 772. So this allows us to easily calculate our probability, 0.275 or 27.5%. Now that we have the probability, now we need to make the prediction of the data. So the way we do that is, well, our probability tells us that if we were to choose these 100 students, that 27.5% of them would be preppy. So the way we express that mathematically is 0.275, the decimal representation of that percent, times 100. We evaluate that, that gives us 27.5. So obviously we don't have half a student as preppy, so we round that to 28, and we would expect that of the 100 students we chose, 28 of them would identify as preppy, and that's our final answer. And that's it for this week. Next week, we're going to look at conditional probabilities, as well as some more advanced applications of what we looked at today. Hope you liked the video. If you want to hear more and see what else we're up to, hit like and subscribe, and see a new video coming out from Point Avenue every week. If you want to talk to us, hear more about what we're doing, or have any questions, email us at contact@pointavenue.com. Bye!